Hi everyone, myself Mr. S. Vanchinathan, Assistant Professor, Department of Physics, K.S.Rangasamy College of Technology, Tiruchengood. Today we will be discussing Module 4 of Engineering Physics, Advanced Materials and Nanotechnology. This session will cover the fundamentals of nanomaterials, their unique properties, and methods of fabrication. The purpose is to understand why nanoscale materials behave differently from bulk materials and how we can explain those properties for engineering application. And introduction, start with definitions of nanomaterials. And nanotechnology deals with understanding and controlling a matter at dimension between 1 to 100 nanometers. 1 nanometers is a billionth of meter. The idea was first explained by Richard Feynman in famous quote 1959, there is plenty of room at the bottom. This is the introduction about nanomaterials. And then at the nanoscale, the density of structure increases, which means more information or material properties can be packed into a small size. Properties such as optical, mechanical, electronic, thermal, and chemical can be explained in the change at its scale. This happens because physical properties do not scale linearly. For example, area and volume scale differently as size shrinks. Optical properties. A classic example is gold. In bulk, gold appears yellow. At the nanoscale, gold particles appear red in color. This is because electron movement becomes restricted in nanoparticles, altering how they interact with light. The color of nanomaterials depends strongly on particle size. For quantum dots of 3.2 nanometer emits blue light, while dots of 5 nanometer emit red color. And then surface to volume ratio, when the size of particle decreases, its surface to volume ratio increases. More atoms are available at the surface of reactions, making nanomaterials highly reactive. This property makes them excellent catalysts. For example, platinum nanoparticles are used in catalytic converters because of their enhanced surface activity compared to bulk platinum. And then nanoparticles exhibit the properties very uh, different from of bulk due to this high surface energy. At the macro scale, the surface forces may appear weak, but a nanoscale they dominate. Such surface atoms are often more reactive. Nanoparticles show enhanced reactivity and unique mechanical properties. Quantum well, quantum wire, and quantum dot. The behavior of electrons changes dramatically when dimensions shrink below 100 nanometer. A quantum well allows electrons to move in two dimensions but conforms them in the third. A quantum wire restricts electrons to one dimensional motion. And then quantum dot conforms electron in all three dimensional, essentially creating artificial atoms. And physical properties of nanomaterials. The nanomaterials often have reduced melting point due to large fraction of surface atom, and their mechanical strength can be one or two orders of magnitude higher than bulk crystal due to fewer defects, optical properties, shift, and applications in displays and solar cells. Magnetic properties also change. Bulk ferromagnetism can be vanish and be replaced by super paramagnetism. And fabrication method of nanomaterials, the nanomaterials can be synthesized in one or two, three or three dimensions. There are two main approaches. The one is top down approaches and second one is bottom up approaches. So top down approaches breaking down bulk materials into nano sized structure, and bottom up approach assembling atoms or molecules into nanostructure. And then fabrication classification. Physical methods include high energy ball milling and vapor deposition techniques, and chemical methods include sol gel and electrode deposition. Biological methods explain DNA enzyme to produce the nanomaterials. And example, ball milling approach. So the ball milling is a classic top down approach. Here high energy balls inside a rotating drum crush bulk solids into nanoscale particles. This method is simple and widely used to produce metallic and oxide nanoparticles. For example, ion nanoparticles with grain size of 10 to the power of minus 30 nanometer can be synthesized using this method. So the bulk materials have low surface area to volume ratio and fewer surface atoms, making them less reactive and softer. Nanomaterials have a very high surface area to volume ratio, making them highly reactive, harder, and less ductile. This explains the nanomaterials are extremely strong and sometimes brittle. To conclude my topic, the nanotechnology offers a way to tailor material properties simply by controlling their size and structure. Unique optical, electrical, magnetic, and mechanical properties make nanomaterials highly valuable in modern applications. Further technologies in electronics, medicines of these nanomaterials. Thank you all.